let's look at another design for gas plumbing, right? This is a very large building. It's a commercial building. It's a pizza place and a bar. It falls under the category of bar and dining, right? You can see from here it is a very long building this direction, right? Then this is part of the architectural file. They went through the stress of breaking it down for us to like look at it closely, because if you zoom in on here, a lot of things get blurry, right? But I mean, they cut it into two portions. This is one, right, from here, and this is two, which is this other part. There's almost two halves, right? So now they now came here and showed us what each of them means, each of them is rather. They even gave it scale, right? Let's see, the scale here is okay. This one does not have scale, but this one has scale, right? This scale is very important. I know I don't usually talk about it a lot, but it helps in measurement. All buildings should be drawn to scale, right? Because the whole point of scale is basically saying that every 1/4 inch, every one quarter inch is equals to 1 foot, right? So that means this could be up to 20 times as large as it is, right? So what this just basically means that if you measure a quarter of an inch here, it is equivalent to 1 foot. Right, so it's important to, and I think I've shown you how to do it, but I will show you again today, right? So this is 1 and 2. I mean, I would have placed 1 here and 2 here if I were the one arranging it, but this is how we came across it, right? This one is the bar equipment, as you can see from here. So this is everything bar related. There's a lot of things really. They even had to start tagging it with numbers, right? With B stands for bar. So you go look closely. I mean, we are not doing the mechanical and plumbing for this building, right? If not, would have gone into detail. This is an ice maker or is a sink, right? This is B16. Okay, this is like, I'm not sure what it is. They actually gave us the schedule to show what each of these things are. That is B16. Let's go for B16 here. Okay, that's a mock chiller, right? So the whole point of this now, they've given us, after they give us all those tag numbers, this is the rest of what they mean, and to show if it's a plumbing equipment, if it will require plumbing, if it require electricity, if it's then the size of the, and this is like for the plumbing, because gas is also part of plumbing as I mentioned before. So the size, the connection size, and then the quantity, the provider, the manufacturer, all that, as I can like research on it, right? And then they went the extra amount. No, this is not what I'm looking for, right? So I mean, let's go back to that page, which is here, right? So then we go into the other side, which is the kitchen, right? So kitchen usually has a lot of gas connections, so we'll see what all these things stands for. Then we'll be able to tell. The first part of this project should be understanding the building, what it is for, what the sections are for, the flow into the building, right? The flow into the building and through the building too. So let's just like, I just want to focus on some things, right? You have K16, K14, and K9, right? These are equipment that require gas. K9A, K14, K16. Let's go and look at them. That's K9, 14, and 16. Okay. K9A. That is this. It is a pizza oven. Right. This is the manufacturer and the model, and then this is the connection 3/4, right? And this is 130, which is the BTU. Remember we talked about the energy consumption, right? So this is this, right? Then you look at the others. So we talk about K9 now. K9, okay. Then K14. K14 is a double stock pot stove. K16 is fryer. I've not seen many of these things before, and I don't know if you have, but at least you can look them up to see how they work, right, or what they look like. So you see this one also require gas, and anything that has something in this column, because this column is a gas size column, right? So that is just how it works. So they also went the extra mile of giving us a schedule, which is this, right? An equipment sheet rather. So this equipment sheet is very detailed. You know, all those manufacturer, this is like this has the manufacturer information on it, right? Because they're saving you the stress of going to look for it yourself, right? So this is that pizza oven we looked at, right? You can see the name MB series. In the MB series, that was MB something. Then we have MB60. Let me zoom this in. We have MB60, MB42 stacked, right? So then if you scroll down, we're going to see the different drawings, what it looks like. Okay, this looks like a hood, like an exhaust pipe or exhaust dot, right? Then you come here, you can see more specifications, right? Then you have the M42 and 60. See from here different. Okay, we don't need all this information, we need the BTU. Go straight 130,000 like we saw there. So this is for natural gas and this is for liquid propane. We've mentioned propane. We've not been designing propane, but in case you ever come across it, you have to understand that propane and natural gas, they are close, but you cannot really interchange them, right? If it's, you ask if it's propane on site or if it's natural gas, and then you work with it, right? Then this is for, you can see there are two sizes, right? One is bigger than the other. That's why they have different demands, right? Okay. Then what else? K9. Okay, let me not waste too much of your time. I mean, you can always scan through it if you it's your turn. So I mean, I recently discovered that, or I recently started to learn how to spend less time, right? So I don't want to bore you with one long video. So let's just do let it be as short as possible. So this is that same project, right? I've already done the design already, so it's just a matter of looking at it, right? So I'll explain what everything here means. So the usual, coming your from city, this is your gas line, right? Your meter is used for measuring the amount of gas that's been used, so that when the bills come, pay accordingly, right? Then you have a backflow preventer, is the type of valve that does not allow it to go back, right? Then we have a PRV. This stands for pressure reducing valve, a very important element of gas pipe plumbing systems, right? I think we mentioned a couple of others, right? You can, in some cases, you can leave out some, right? And then the person installing on site would use that discretion to, find out. Like there are some good case practices, obviously, right? And then there are some things they cannot do without, right? But it's important that you show as much detail as possible. But that if you show everything, it gets too cluttered. Remember, we have flexible connection here, so it is how you connect to each of the equipment, because in case of vibration or in case of moving, because if you put rigid pipes, it's going to like result in cracks, and you can't afford to have that kind of system, right? So then, okay, those are our equipment we spoke about. This one is the pizza oven. This is the smaller pizza oven, and then this is, okay, this one does not require gas, right? And we can go through the equipment schedule in your own project, right? But I'm not trying to waste time today. Okay, then this is the stove pot and this is the fryer too. Okay, this looks like an equipment that requires, okay, this is a sink. Okay, so it continues on its journey. This is the main pipeline. It continues on its journey. This is a walking cooler. I mean, I would have loved to go in about a lot of these things, go on about a lot of these things, but you're not doing M or P, right? When I say M, I mean mechanical. When I say P, I mean plumbing. So this is a bath, right? I mean, you can, if you want, I can send you the card file to try it out, right? So you continue, and then up to this point where we have the final water heater. So this is a note. Okay, this is one of the areas where mechanical drawing has an intersection with other drawings, right? So this concrete platform is supposed to be coordinated by structural or civil team, right? So I mean, there's always different teams working. There are always different teams working on if a project, right? So this is just me like pointing whoever is looking at this to the fact that I'm not the one coordinating it, right? The thickness and the details of that slab, but there shall be a slab because this is a really large water heater. Don't mind how small it looks here, right? So I mean, this is all. Then these lines, I added them to help me arrange my file or my layout on the page, right? So now let's go into sizing of the pipe. Okay, this should be it. Sizing of the pipe. And here I spoke about okay, we'll talk about soon. Okay, before we go into sizing of the pipe, let's show you what each of the pages looks like. I can also just talk about that skill I mentioned earlier. So I have some notes here. Then just little notes. I mean, as time passes, you develop your notes, you include new information, right? There's even a note I formed. Where is that note? See here. Okay, it's not here. It's on another project, right? And I would like you to also think of notes that you can add to your own project to make it, to make it more detailed, right? To provide as much information as possible. I mentioned some information. Let's see if I can still find that. Okay, I mentioned some basic elements or basic parts of a gas plumbing system. Refer to the previous video for that, right? So those are the kind of information, those are the kind of details you like form notes for them. You research, obviously, check the codes and look through like manufacturer information and see how you can design and like set information or include information to ensure proper design, right? I mean, this is something that works with your discretion, so I won't show you that because I want you to decide by yourself, right, how you present it, right? You know how we have our layout for plumbing. This is a very okay, perfect. See all these many notes is over time that they got formed, so you too can have a similar note for gas plumbing. So right, I mean, the more the better, right? To the point, this one it doesn't have a lot of notes. That's why I didn't devote its own page to it, right? So as I was saying, right, this is what it looks like. You see how different it looks when it's on the layout, and when I print it out, this is what it looks like. The green stands out because I used Truecolor for green. I've told you how to select this, but let's just look at it again. More colors. So this is Truecolor. So when you select anything under this Truecolor, the color it will show the way it is. But if you select another index color, it will show only on the model. But when you bring it here, it's no longer, it will be in black and white, right? So this one, you see, select different ones are selected, right? So that's why I selected this green from. Because if you notice, we usually use green for like layout of our plans, right? But it does not usually show up as green on this, right? Then another thing to also consider is okay, you right click on this, then you activate page setup, then you modify. This is another place that I can make changes. So grayscale means that whatever you are doing is going to, what the layout, the printout is going to be on a range, a scale of grays, so from black to white and then everything in between, right? So in this kind of layout or this kind of color setting, there's also monochrome, which is strictly black or white. For this one, if it's a dark color, it will show up as black, but if it's a bright or a light color, it will either be visible, which is white, right? Then grayscale allows for like a higher range, right? So I mean, that is important. I mean, other things you know it already, right? So yeah, so these are gas meter, then our PRV, which is our pressure reducing valve, very important at the beginning, at the entrance where the gas is entering the system from, right? And this is even usually more for very large projects where you have different zones, right? You know, zoning is always important in any type of system, right? For larger projects that have zones, this one I just put everything in one zone. You have to put this right in at the beginning of each zone because it's just like fire alarm too, because they might be, because a gas plumbing system is a sensitive system, right? So they might be need to turn off something in the case of maybe, and then there's also pressure relief valve, and a lot of other type of valves too for when pressure is higher than it should be, right? Because it could lead to an explosion or whatnot, right? So okay, so this is how it's laid out into the pizza oven, the water heater, the pizza oven. Then we also have this stands for makeup air unit, right? This is a large kitchen. I mean, if this was mechanical drawing, I would have explained it more in detail, right? This entire space from here to here are all cooking equipment. Okay, not all. This one is not, but it's something close. So we needed to put in a hood that contains. I didn't even find one hood. I had to put two side by side, right? So you can imagine the amount of air that was leaving due to the amount of the size of the hood, right? Let me even look at it. Never mind, right? You can imagine the amount of air. So there was need to add a makeup air unit because that would have created a lot of imbalance in terms of the air in that space. So now makeup air unit, some systems come with their own, but it's usually not some, like some hoods. That's what I mean. Some kitchen hoods come with their own makeup air system or air unit, right? But it's not, the air will not be conditioned in a lot of cases. And if the air is not conditioned, it's going to, when it comes in, the air comes in, it's going to disrupt or disorganize the existing temperature and humidity in that space, right? So the makeup air unit is like an AC of its own, right? That conditions the air before bringing it into the space. So this one is on the outside, right? And then it really, if it's it also has a furnace, right? A furnace is where gas or fuel is burnt to generate heat, right? So it's as part of the system, right? So that is what is used to heat the air, right? So I mean, a lot of we've not talked about it a lot, but a lot of your air handlers have heat pumps, right? That is for the ones that are split. We also have packaging where they are both together, right? So one is the air distribution module, which is the air handler, as the name implies. The other is the heat pump. That heat pump is where the heat addition or removal takes place, right? If the room is hot and needs to be cooled, that heat that is being extracted from the room is being rejected at the heat pump, right? And if it needs to be heated up, the heat pump also like does like a reverse cycle to send in heat into the space, right? Now there are still other types of equipment that can be paired up with a an air handler to provide or remove heat, right? There's the furnace, there's heat pump. What again? There's a lot of, we dealt with these things in when we talk about HVAC systems, right? So let's not dwell on that. So this one apparently requires gas to create heat, right? So that's why we added it to our system, right? So I mean, you just pointed out this. So then our water heater. I mean, the water heater, when you are selecting the location for a gas water heater, because some systems, some clients and some locations require gas water heaters because of presence of gas, obviously. I mentioned why gas is also usually used before, right? Because it can be cheaper. So now when you are selecting location for your gas, for your water heater, rather gas water heater, select the location that works for both the plumbing system and for the gas system too. Right? So you just have it in mind. Right? Even if you're not the one designing the gas, try to make it easier for the person doing that. And what do I mean? Me, generally, specifically, personally, I like to put anything gas closer to the outside of the building. I don't like it being inside the building because I don't want the gas pipe to be run inside the building. Although there are some cases, luckily for me, this is a long building, so the building does not have a lot in width. So I mean, you don't need to. But there are some buildings that can have large, maybe a square type of, for example, this part now. If you had something here, you would have had to connect pipe inside of it, right? But I like to avoid that as much as possible. But if it comes up, I mean, you have no choice, and then we hope that our system is safe enough to handle it, right? I mean, this is in case there's a leakage, right? So let the leakage happen so that the gas leaking will go out, right? Although it can also make it difficult to sense too, right? Because if the leakage is inside, it builds up and then somebody can perceive it. It's also a hazard, right? But somebody can perceive it and identify. But if it's going outside, the gas can just be wasting from there. But still, as we always say, safety over cost, right? If you have to pay extra for safety, please do, right? So yeah, without wasting much of your time, I think I've wasted a lot of your time already. Let's go into the sizing. Okay, before we do that, I wanted to show you something else. So this is how I arranged it. You may come across a large building like this. I discovered that I can put everything here, but by the time I print it out, somebody will have to zoom in, and paper, they will print it out on the physical paper in some cases, or they will look at it on a computer screen. We have to zoom in to see some of this, and you see that they are already very blurry. So I now had to, divide my own into two like another person, and this is what I use these broken lines or these zigzag lines to do that. So from here, I showed it here, so now I can see that things are more visible. I mean, you could do it into more, maybe into three places, maybe here and here, so that you can zoom in more. So this is what this is a good example of scale. So you can see here, the scaling is different, 1/8, right? Because I'm okay, let's double tap and show you. When you double tap, you see 1/8 is here. See where my mouse is? Here. And this is where you set it. If you can change it to either zoom in or zoom out, right? So you go back to model. When you put it back on model, if you zoom in here, it does not affect it, right? But you now come here, the scale is different, 1/4. So 1/4 brings it closer. So means if I've gone as low as or as high as 1/2, let's see what is, and it's arranged accordingly. So you come to 1/2, it's going to even be closer, right? But if it gets too close, if it gets too close, it begins to like be outside you have like an outline, your boundary or your border. If it gets too close, you some of the information will be outside the border, right? So that's how you zoom in to keep it within the border, right? So I mean, feel free to choose whatever works for you, right? Okay, let's go into sizing. I just like to make you understand the whole point of, because I believe in learning. It's not just knowing what to do for this. It's about understanding the concept, everything's around surrounding that information, so that in case you need to apply it elsewhere, it's just a matter of rearranging that information and applying it to the new circumstance, right? So yeah, I have this habit. This is just my personal habit of having these around, so I can always refer back to them if I want, without having to search for a different um, document. Of course, I have a mechanical template document here also, where I just fill in information on maybe all the air handlers I've worked in, the sizing, then the water heaters too, and the sizing too. So if I need to, I can just come here and just cut it out or copy it out and take it to my this thing, right? So I mean, it's just a practice I developed for myself. Nobody taught me how to do it, right? But I'm showing you, right? So yeah, let's quickly look into this. So now this is, the other one was over a lot of distance, right? No, are we looking at the right thing? Yeah, that was a lot of distance, right? But this one, did I save this thing? I think I made some changes. I don't know if I saved it. Okay, any changes that we need to make, we'll make it here and now. Right? So now this is everything. This is schematic, short summary of what we have, every information shown here, right? So let's look at it. This is the gas meter. Then we have our different items laid out. This is more to give you better understanding. Our pizza oven, water heater, and so on. Then we label. I mean, you can always do this by yourself, so I don't have to start labeling it here. You can draw lines. All these are just lines and text. You can draw it by yourself. Right. This is a branch. This is a junction. Right. So for the first one, we measured it obviously. Length. This distance now is the distance from the gas meter to this junction to here, like we said before. See 2 feet. That is this branch. This 27 feet is this distance, so it's 29, right? Continue like this. This one will be 29 because it adds up along this distance, right? So then this is the BTU demand for each of them. And if you notice at the beginning, it is the highest, which is 1546. This is supposed to be in kilo BTU because this is in thousands. So kilo BTU. Let's change that. Okay, let's move it. Okay, this is kilo BTU because this is times 1000, right? You want to write too many numbers. Okay, this is these are the different demands for each of them, and then if you notice, this is the largest because this is the sum of all of them. This is where the largest amount of demand is. Right? See that this is a very large system. right? So we have our gas sizing. Now let's size, assume that these pipe sizes are not here. You just need the demand and the distance, right? You know how the distance is gotten: 27 to 2 feet, 4 feet, 4 feet, 2 feet, and if you see it's increasing in this direction, right? That is how this distance is also increasing here. This one, because it's adding as you're going. So basically, the way this works is that the largest amount of gas is at this beginning, and as the distance increases, the gas drop, the pressure and quantity, everything drops until it reaches the last, right? So we have to set a system to carry it until that last, right? So I'm saying sizing, you start from this last and then go to the bigger part, right? The larger demand. So our first is 365,000 and is what distance? 104 feet, because this is the entire distance. So it means this 365,000 BTU has to travel a distance of 104 feet to get to this point, right? So now let's size the pipe that will carry it to this point. So I already opened up, yes. So please don't tell me this. Okay, so we are using a metallic pipe before we use semi-rigid copper, right? Yes, right, yes. So we're using metallic pipe because the bigger system. Metallic pipe is more durable and is able to withstand higher pressures, right? So let's look at it. That was 365,404. Now this is 365,000. Remember that you divide it by 1034, right, to convert it to CFU, because this is in CFU, right? So when we divide it, let's divide it and see. I mean, you already know how it works, but let's just no. Okay, so that is 365,000 36, okay, 6 5 1 2 3 divided by 1034 equals to 352. Still close. So I mean, if you look at 352, right, we can get what we're looking for. You see, this is in CFU, cubic feet per hour, CFH rather. So that is 300 and what again? 352 or 53, right? At a distance of 100 feet plus. So this is it. So this is 100 feet plus. So you go to 125 because 102, so 104 is slightly above, right? So we come here and check our demand is 365,000. So we don't need to, if it was more, would have gone down this, but it isn't. I mean, it is okay. So that means the pipe size will be half an inch, right? Half an inch. Let's go back. That is why we selected half inch for this. So that is the size of pipe that comes all these points will be half inch, even here half inch, right? So we now come to the next, and let's solve for this too. And this is 136,000, right? So 136,000 at 43 feet, right? Let's check. 136,000, first of all, find it here. 136, 123 divided by 1034 goes to 131.5, 132 at a distance of 43 feet, right? 132, 43 feet. Where is that? Okay, this is it. 132. Is it 132? Yes, 132, 43 feet. So this is the distance. 43 means it to be around 50. Then 100 and it works. This works because this is 653. It's greater than. So anything 100, 200, 300, 400, 500 will also work with a half-inch pipe. But by the time it crosses 673 and enters, it'll be like the demand. If, for example, now we had maybe other things along this branch that would have made it to have more. I mean, there are sometimes you might have like complex. This is very simple, a simple branch, just one device per branch. But you can have cases where in a large system you have more than one per branch. So this, remember, we've come across such in plumbing. So for example, the branch of the main line, and then there's WC, there's water closet, that obviously, then there's lavatory, and then there's a bathtub along that line. So that means that's going to give us a total. So if you have such in that case, that means we would have had a larger demand. And that larger demand, if it was more than that 700, would have increased the pipe to 3/4. Now, this, don't confuse it because it's easy to confuse. This won't have inch is for the branch pipe itself, not for the main line. That's why you have information all over, right? Now for the main distribution pipe, let's check this one. I will size it with the total of this guy plus this guy, the demand 136 plus this, and that gives us 501, right? 501 kilo BTU, don't forget. So now that means for sizing this part of the distribution pipe, we use 501,041 feet. So 501,000, let's check again. 501,000 divided by 1034, right? Enter. That is 484. 484.5, 485 over a 41 feet distance. So 484, right? 41 feet. 41 feet is around here too. So that is, we use 50, right? 484. You see, it's still large, but it is not larger than this our value. So we can't go into the next column, which is 3/4. That is why our pipe remained at ½ inch. So it means this all this distance is going to be ½ inch, right? Because this supplies this guy and then supplies this guy. But now, so we keep traveling back, the pipe size should increase, but it increases only when it has crossed the line for it to increase, right? So at this point, 160 for 41 inch, which is close to this, you don't need to be told. It's a no-brainer that it's going to be ½ inch also, but you should still confirm, right? ½ inch. Now for this guy, you see that we've got it to 661,000, and our highest value here is 673. Very close, but this pipe can still carry it. That's why we still have it at ½ inch, right? ½ inch. But by the time we get here, it has crossed that mark, right? It has crossed that line of 600. It has not entered 921,000, and this is because at this point the gas demand here is consisting of this guy, and this guy. Okay, this point is even includes this guy too, because this branches off and then this branch continues and supply these three. So that means this place is carrying 1, 2, 3, 4. And when you add them up, it gives you 921,000, right? And then now let's check it. 121,000 over a distance of 37 feet. Let's check it. 921. Okay, let's convert it first. But you must have noticed a pattern now, that most times our value is not usually far from the kilo BTU value. So this now, because you are dividing it, kilo BTU divide by 1000. But in this case, you are dividing by 1034. So if you notice, to still be close, which is 890. 890 is close to this, but you should not assume, because I mean this is still a large gap, difference of 30, right? Imagine if maybe the pipe for 3/4 starts at 800, or for example 1/2 ends at 8996, and then you now assume that since they are close, you now take 91. It means you're supposed to use a larger pipe but use a smaller pipe. So it's important you still check it, right? So this is in the 890,000 CFU over 37 feet. Let's check it again. 37 feet is around here. 89, it has passed this, so that's why we're entering this, which is 3/4. Right? And if you notice, as we keep going towards the gas meter, the gas demand is increasing, but the distance is dropping. Remember, we started at this point, but it's dropping until it gets to the smallest distance, right? But this will be increasing, right? So if it increases very much, it will be going in this direction. But if it doesn't increase so much so fast, it maintains its column, right? Or it jumps column one by one gradually, depending on the demand, right? So this will be 3/4, right? And so on and so forth. But you also notice that as this is 3/4, the pipe off of it, the branch is 1/2, because as you can see, this is still close to this value. Let's still confirm it. Always confirm, don't just assume. So 260,000 for 39 feet, right? 260,000, 260, 123 divided by 1034. Okay, 251,000 over 39 feet. So 39 feet around 40, 251. It still falls here. So as far as you have a distance that is under 40, and you have demand that is under 753, you are going to use a half inch pipe or less. And you see, this is the smallest pipe, means you can never go less than it, right? So that means that is just saying that as far as none of these things exceed that 700, or that you mean that they will always be half inch, right? But still confirm, right? So yeah, that is pretty much what it means. So come here. I mean, it increases until this point. So now for the first point, the highest point, let's see the sizing, confirm the sizing. 156, 1546, 1546. We have to confirm that it meets our it is already enter 1 million. 1546 divided by 1034 1495, then at a distance of 27 feet from the gas meter, right? 1418 1495 27 feet, so 27 feet is somewhere here. 30, so 1495, you have crossed 869, so it can be a half inch pipe, and then you have entered there. So 14, it falls under 17, so this works. 3/4 inch pipe works. But if it had crossed 14, enter maybe 18, it have entered this 1 inch pipe, right? So I believe you remember how to measure these distances. These distances, I didn't manufacture them, I measured them, right? So let's go back to this thing for me to show you. As I measured this distance, all this distance is 27 feet, right? 27 feet. Then this one, let's see what this distance is, right? Okay, let's just see this one because it has this. Oh, I forgot to mention, there's always, when you are changing directions, you shouldn't make it abrupt. It's not a sharp change, right? It has to be at 45 degrees. So let's look at this. This is angular measurement. So let me show you that it's 45, right? So this is 45 because if you 180 minus 135 is 45. So this, if this is 135, it means the remaining is 45, right? But that's not what we need for this. We're trying to measure this distance. So let's see. Remember, there's linear and there's aligned. So linear works for horizontal and okay. That is because it was not showing me the points I wanted it to click. Okay. This direction. Linear, that's horizontal or vertical. So this is 3 feet. Then press your space bar to repeat the command. Then you measure from here. Alright, I didn't skip it, I'll come back to it. To here, which is 23 feet 5 inches. And then let's use align for this because this is not horizontal or vertical, so it's inclined at an angle. So this is 2 feet 6 inches. By the time we add up all of this, you're getting something around 27 feet, right? So yeah, that's to show you that I didn't manufacture those values. And if you go up here too, you can measure this distance and confirm too, and you keep measuring as you keep going because these are branching off. When you measure here, this is a branch. When you measure here, this is another branch, right? So what else? Okay, now let's look at the riser diagram for this project. So yes, so I mean, this is our main line. Don't mind me that it starts up here. It actually runs underground because it cannot be in the air, obviously, from the city, the main distribution network, and then it supplies our system. It comes here, it drops gas for the pizza oven, then it moves forward, drops water heater. Now if you remember, these are the branches to each of them, right? And then this is the main distribution line, and you notice that change from 3/4, 3/4, 3/4, 3/4, 3/4. Oh, it's supposed to change. You, my bad. So at what point did it change? Let's confirm from here. It changed to 1/2 after it had, at the point where it dropped, it gave our makeup air unit. So it means from that point forward supposed to be 1/2. So it means from here supposed to be 1/2 inch, right? The truth is that, okay, it's supposed to be more there. The truth is that neither oversizing not on underside. Okay, yes, you actually need to. I did this on this is actually on the model, so that's why I had to double click if I can edit it. Alright, so this is supposed to be half. Okay, half. Okay, can edit from here. Then you can also see, you can edit by the time you turn off that model. Okay, you can also do it by clicking paper. If you zoom in at it will zoom in, the layout will zoom in, but I don't want that. Right, so I mean all of this supposed to be 1 inch, half inch rather, from here. So you change it 1/2. Then same thing here too. Over 2. So now you click your model. So I don't change it because I already arranged this page. I don't want this thing to move around too much at all safe. Although this one is not to scale shot, there was no need to add scale, but I still use my own scale for it. So this is our riser supply layout. Right. So that is basically what it entails. Is there anything that I'm forgetting? Okay, notes. Alright, I'll leave that to you because that is proof that to show that you understand what we are doing here. So I mean, I believe we've come to the end of today's class. Let's see if there's anything else.